Hello, everyone, and welcome to the video about computational methods. So first, let's take a look at a research that's been published by a good friend of mine, Andrew Marks and Melissa Rogers. In this research, they are looking to see if a reporting of Panama GDP is actually correct. So it's very interesting, right? Because you're looking at the data from the United Nations, for example, right? Then all the countries have to submit their GDP data. Well, some data might be fudge, but we don't know whether it's fudge or not. We have a suspicions. Can we really confirm or deny, right, these suspicions? So with that idea, right, they're looking at night lights, right? So looking at satellites data and see, well, if we can have some sort of equivalence of nightlights reporting, can we see that the Panama's government are doing accurate reporting or not? This imagery, right, satellite imagery, looking at the data and then looking at how are they reporting the data, we're looking at it, right, and the results seeing that, well, between 2012 for a 12-year time span, there are 19% more GDP that was reported by Panama versus, right, a quote unquote the nightlife productions. So, is an equivalent of, we're saying that, well, can we use something in the trace data of the real world, right? And this is not talking about, data that we use, right? Usually, text or voice, right? This is like media image. So this is satellite images. So here, right, the results is it's quite interesting because here just a little bit from saying, well, the government here in Panamanian government actually doing a political manipulation to make sure that the government stand out well. So it's very interesting, right? See, the idea that we have with computational methods can come with different sizes, and this is one of the ones that are quite interesting and it's not fits into the box well of what has been done. It's called traditional research. So what is traditional research? Well, as you and talk and discuss with our overall course, right? Traditional research is really all about thinking carefully about the study, and we're gonna get the data and we'll collect it through the design study. If you do quantitative, you have to design the study that you can collect quantitative data, right? If you do qualitative, you have to design a study to collect qualitative data. Now, research in trace data are different because trace data are just byproducts of everyday's action. It comes from all shape and size. It's a matter how you use it. The data is big, as a big data, right? But the problem is might be incomplete, it's dirty, right? It's drifting, and it's algorithmic confounding. And these needs to have a little bit more processing, as you say, so we can create a sound research environment in order to leverage trace data. And that's what we come to computational methods. So let's take a look at these traditional data and trace data, right? These are different. Traditional data used for study social things. Trace data to study anything at all. Traditional data is using question driven, right? You have a questions, you get the data. Trace data actually is more on a methods driven. You have the methods, right? And then you try to find the data that you can use with that methods. A little bit different, right? Traditional data is very small, right? Very designated, the data collection process. Now, with trace data, we find the data in large oceans of data out there. We're going to use it for our research. Traditional data is more an explanation, right? Causation as well, in such form that we can conclude in a very scientific matter, for lack of a better word, but also, right, very confidence level with statistics built in. But however, right, trace data is more on prediction focus, right? We're doing data, and then we're trying to predict what happened next. Traditional data are being used usually by what we call social scientists. Trace data, right? A lot of people call it data scientists, right? But these days, these two terms can be merged together. The problem here is that social science itself, right, is starting to not being so sufficient because data can only get bigger. Now, the data science is not sufficient because it has to be rigorously tested. If we just use, any data at all, right, without rigorous, then it's really hard for people to, take the computational methods seriously. So then the two world merges together, and we call it computational social science. So when we combine these two together, social science, data science becomes computational social science in order to leverage both the data so we can use bigger and more available data and also study social behavior more rigorously. Okay, so let's distinguish between explanation and prediction through a simple case of linear regressions. So here, what do we have is a plot lines between two different variables, height versus weight, right? So we have all the red dots signifying between the height of a person and the weight of a person. The purpose for the linear regression is always about fitting that line, the blue line, with the least error through the data. So here you see here that we have a formula with a different type of R-square. So the explanations are really concerned with the R-square, right? And the statistical significance, they want to make sure that the R-square is really high, right? And then it can expresses the power of predictions. Predictions, however, doesn't concern as much about the R-square. What it concerns is how this formula can be formed and how would it be translated later when we're using this formula to predict other information of other people's weight and heights outside of this data that we collected to create the formula. And that's the main difference between exploration and prediction. Other questions we can ask, for example, can search predicts the revenue, right? So here we will get movies, video games, and music. If we fit the line through it, it's hard to know, right? Because we see here's a research rank and the predicted value, and then we're looking at this, well, we might not be able to see a very clear process just yet. The problem is that we ask the wrong question if we ask, can search predict revenue? The better question to ask is, can we use search to improve a simple baseline on predictions, right? So here on top, these are the baseline. And at the bottom, we are adding search into this baseline and see, well, can we use search in order to predict, right? As you can see here, right, movie doesn't add much, video games slightly a little bit, but music actually with search, right, increases the baseline quite a lot more. So this is type of right questions that we should ask when we're doing things in computational methods. At the end of the day, the prediction should be compared with the baseline. So here's the summary. Computational methods is using trace data with a prediction focus to understand a phenomenon that you are asking about. The large movement in research here is usually called computational social science. If you search on computational social science, there is a community of researchers are using data, like trace data, in order to understand the world that we live. And the prediction in computational methods should always be compared to the baseline. And that will help us understand, well, how well a prediction has come in order to have a very successful computational method results. So thank you very much and see you in the next video.